curiosity. I would have liked to know all those things, but fine, let's move on. So let me introduce the agenda of the workshop. So there are three primary reasons why you should what this agenda was going to be covering. First is to introduce the participants to full stack, software development lifecycle. Second is help participants do better in hackathons, as you can learn, the frameworks, the libraries, the programming languages here, and the best practices to do that, and allocate more time in hackathons for actually implementing your idea rather than doing it there. Because when I was a student, I wanted to go to a lot of hackathons, and I did go, but I was constrained by my lack of, practice and experience in actually developing things. Theoretically, it was fine what we learned in college, but to implement that, it required some external help. And also, the one of the things is to expose the participants to what a daily life of software developer is, and some of the tech stacks and some of the jargons that is being used. So let's move on. So let me, since it's the first session, I just want to make it clear that this workshop is not intended for learning the fundamentals of computer science. If you like, for example, networking, databases, algorithms, etc. If so, please pay attention in your class. That's the best and the most important place to learn the fundamentals of computer science. If you're not in a CS or an IT department, there are plenty of courses available online. That's where you should start. And the second thing is that if you are not unable to commit to a long-term learning, because this workshop will happen over a course of a couple of months at least, and you will be expected to attend the sessions, do some level of self-learning and work on your own personal projects that you can present at the end. So if you're unable to commit to that, it would not be a best use of your time. And third and most importantly, if you're very interested in programming and data structures, right? If you're targeting big FANG plus companies, and if that's your primary goal, then focus on that, because that's what will help you with those companies. This is for a general curiosity, general learning. Of course, learning this will give you an edge over the others for those who don't know this, but stick to what you want to do. Okay. So, programming versus software development. So what's the difference, right? Because most people just think if you're a programmer, you're also a software developer. Or if you're a software developer, yeah, you will be doing programming, but not always. And there's a lot of peer pressure and misunderstanding that all those people who do competitive coding, programming, will definitely help you, when you actually start your job. It might help you get your job. I don't deny that, but will it actually make you a better developer? I actually wanted to have like a QA session with the participants so that I can hear what they say, and they everyone can be on the same page. But yeah, so I am assuming some of you might think that way, but let's find out. So I just took the definition of what programming and software development from Wikipedia. So don't say something is wrong. Wikipedia says computer programming is a process of designing, building an executable computer program to accomplish a specific result or to perform a specific task. So basically, for example, if you're a programmer, you write a program to compute the GCD of two integers, example. That's very simple, right? But software development is not just programming. Software development is process of conceiving, specifying, designing, programming, documenting, testing, bug fixing, and creating and maintaining applications, framework, and other software components. It's a lot more complicated. It might sound a little bit boring, but that's how it is. But you actually get to work on a big project. You actually achieve something, right? Programs are very trivial in that sense. So if the amount of pride and happiness that you get when you actually launch and ship a project is very gratifying. So you should all look not to be just good programmers, but also very good software developers. And companies, especially big ones, are very conservative in terms of hiring. They look for people who are the best software developers and not necessarily the best coder. They do have a standard of a competence in coding, but then it's just a standard, right? Anyone above that, they look for the people who are the best in software development. And so programming is kind of easier to learn in the sense that it's being taught in college and there are other easier avenues to learn it. But where do you become a good software developer, or how do you learn it? This particular workshop is one place that where you can learn on those skills. So moving on, so what's expected of an SD? So if you're joining an organization as an SD or a software development engineer, what's kind of expected of you? So how will they evaluate you whether you're going to be a good software development engineer or not? Based on a few aspects. First is that you'll be expected to work on clear and well-defined problems and independently solve them with occasional guidance from others. You'll be expected to design simple and low-level services and applications that are straightforward. You need to be able to write clean production guide code, maintain the respective tests, and also you should be having very good debugging skills and find bugs that might arise from your uh, work or from others' work also. You should also be constantly learning and make smart decisions on optimizing solutions and justify them. The company will evaluate you based on these things before you join, and after you join in a company, this is how you will be evaluated, and based on your this is how your performance evaluation will be done, promotion, etc., and others. So this is a very important skill. It's an important set of uh, activities that you should be aware of while thinking of becoming an SDE. So these are the things, these are the roles, and these are the kind of co-workers that you'll run into if you are trying to be an SDE or a full stack engineer or whatever. So I just wanted to clear a few things like SDE stands for software development engineer, QAE is quality assurance engineer, SDET is software development engineer in test. Uh, an SDET is kind of a mix up of SDE and QAE, but I don't want to go jump into that, but I just wanted to be aware of the different jargons. So then you will run into a full stack engineer. Uh, Again, I will go into what a full stack engineer is. So then you learn work with DevOps engineers, technical support engineers, data engineers, ML engineers, UI UX developers, and engineers. So it's a very wide role, and this is just the SD related family, right? I'm not talking about the program managers, business analysts, software development engineers, software development managers. There are a lot of people that you'll work with. I'm just restricting myself to the technical roles that you will see. So among the SDs, right, there's a lot of variety and scope. You'll be looking at people who call themselves backend developers, front-end developers, Android iOS developers, big data developers, BI developers. BI developers are the ones who will work with visualization of data and related others. So who are or what is full stack development and who are full stack developers? So there is not a clear cut definition of what a full stack developer is or what they do, right? It varies from company to company, from organization to organization, from project to project, and from time to time, right? There's literally no clear cut definition of what exactly they are restricted to. In some companies, full stack engineers just work with one set of frameworks and libraries, and they integrate the front end and back end. It's usually like that, but not always the case, right? So for the scope of this particular workshop, we are going to assume that a full stack developer is a front end and a back end developer put together. In certain places, you will see them doing BA level work, that is business intelligence sort of thing. They might be doing some level of machine learning, some level of big data, some level of cloud support, some level of technical support. There are a lot of things. So the scope of this workshop is to how to build a functional project from scratch. Uh, there'll be 1 hour sessions on the weekends to introduce a concept. Expectations from you is that you'll work on your free time on this project so that you can learn and present it at the end. And I'm not sure if there are some prizes for it, but we can wait and watch. And this isn't going to be a fully comprehensive like boot camp as such, but more of a guide towards self learning.
Yes, Vignesh, we have some five prizes.
Wow, great, ma'am. And
Okay.
yeah, so all the participants, you should definitely aim towards getting those, right? Okay. So what is the tech stack of the project that we are currently looking at? And this is a disclaimer. This might be subject to change based on the volunteers that come forward. But right now, we're looking at designing a client server based application. For the backend, we might go with a REST API based microservice based on Node.js or Python. The data store, we are looking at something like a Postgres data store. Postgres is something similar to MySQL, as in it's an SQL based database, but it's free, open source, and widely used. We'll also be, giving you an idea as to how to, design a clean and consistent UI using some tools. Not sure what exactly might be Figma, and implementing the UI, developing the UI using React, integrating the backend server with the UI, right? So through API calls, and also building and deploying the application. Okay, let's move on right now. So, what are the things that we should know before we get started? We should know Git, what it is, and how to use it. We also need to, store our code base, and collaborate with others and those things. So we can use GitHub, GitLab. There are a lot of plenty of options available. So we'll go with GitHub today. We'll also use some tool to track the project development and project management, right? There are many options available, Jira, GitHub, etc. We'll stick to GitHub for today. And also a system design tool, right? So you want to build a system, you need to be able to know how to do it, and document it. So that's a very important thing. So we'll be using something called raw.io, and it's recently changed names to appdiagrams.net. So I'll be showing you how that works. So Git, to be honest, right? Until I started, I mean, I until my third or fourth year, I had very little to no interactions with Git. But when I actually joined the industry, this was a very essential tool that almost everyone needs to know, because it's used ubiquitously across most organizations, right? There are other alternatives to Git available, like Mercurial, etc. But Git is right now the de facto standard. So if you are interested in doing software development, not just software development or anything related to that, you need to be aware of Git. You need to know why it's used and how it's used, and the more you know, better it is. So to answer some of basic questions like why do we use Git, right? To deal with multiple different conflicting versions of the same code base, right? So we can have different branches, a Git itself, to give you more depth, is basically developed on a Merkle tree, and it was developed by a person called Linus Torvalds. So he's the guy who came up with Linux. So Linux and Git are highly have a similar origins, to be honest. And also Git will be used to collaborate with your other teammates, right, over to remote branches and other things. So that's the reason why Linus came up with Git. And also you need to be able to store and sync your changes online or to other machines, right? So if you suppose your laptop where you're writing your code gets destroyed, then you don't want to lose all your changes that you might have worked on for a few months or years, right? So that's one reason that Git is being used. And also, let's now get started with downloading Git on our machine. I don't know if it's possible for me to paste that particular link that we have here. Let me try copying this and pasting it in the chat, but unfortunately that is disabled. So it's pretty, if for those who haven't had Git installed in the systems, you can just go to Google and type Git download, and you can do it in a matter of few minutes. So I will probably wait for a couple of more minutes. It's 12:24 right now. I will wait up to 12:26 to give you all some time to get started with Git in your machine. Makes sense. Okay. So let me wait. Meanwhile, for those who are already started working with Git, there is or who want to hone their skills in Git better, I would suggest this particular website called getexercises.france.com. Again, I would like to share the link with you, but I am unable to do so. Uh, but you can just type get exercises into Google, and this is what you would first come up with, right? And so it tells you how to set up. So you can actually clone it and put it in a machine and even do it in your local machine. So it has a list of exercises that you need to know in order to become a full-time user of Git, right? So I'm let's waiting for the time to. So we'll go over some of the exercises here, right? So Git start. So whenever you have a Git repository, right? You start off with a called git init. So basically, you're initializing the repository in the particular uh, uh, file that or a file system or a folder that you have. So that's where you're creating a git repository, and all the changes will get start tracked. You'd also want to have a git ignore file, but I don't want to go into the details because I'm not sure where exactly everyone is with regard to that. So I'll just wait for a minute more before I move on. Ma'am, is it possible to enable chat at least, if not audio, for the participants? Because I like some kind of information whether everyone is able to process or if they are stuck or if they need more time. It would be nice to have some sort of feedback. Okay.
Sir, do we use Vim or can we use Visual Studios?
You can use anything that you're comfortable with. I would suggest not Vim because Vim might be a little bit complicated when you're starting off initially, right? So I would suggest you go with Visual Studio or Notepad or anything that is available that you're comfortable with.
Vignesh, let me check and let you know. Okay.
Sure, ma'am. So if you have installed Git in your machine, right? So I can show you how we can start off with. All you just need to do is in any particular repository that you're working on, you just need to do a Git init. So basically, this has initialized the Git in this folder, so that all the changes that I make will get tracked. So I let me create a particular file here. So I'm just going to call it cat.python or yeah. So let me see what we have here and let me look at the git status of the file. So right now Git gives us an ability to track and untrack files. So only in files that we track, we can store it, we can commit it, and move on. So I've created a file called cat.python. So right now the file is empty. Uh, so if you see the file is empty, but I still want this to be part of my commit and I want to share it with my teammates and other things. So let's see what I'm doing. So the status of this file is still not tracked. So in order for me to track it, let me add now if I type git status, this change is ready to be committed. And if I want to edit this file, right, cat.python, let me do that. I just say print hello world. Let me save it. Right. So if I do git
Sorry,
status
sir.
again,
Sorry for the interruption. So, like, only from the people from SSN right now will be able to access the chat. from next week, they will be able to access, people from other colleges or universities, they'll be able to access the chat from next week, from the next session, because they have to join the teams individually, so that in order to access their chat.
Okay, got it. I was under the impression that this would mostly be SSN students, but more by Maria, so it's cool, fine. Uh, so right now, if you see, I have created a file called cat.python. I have added cat.python to be committed, but it's still not committed yet. And I went back to cat.python, I made a change. So this previous version of cat.python is the one that is ready to be committed, but this is empty, but I've modified it again. So if I want to, move the changes that I made to the version that is ready to be committed again, I need to do git add cat.python once more. So if I now do the git status, I just have one version of cat.python that is ready to be committed. Let me go ahead and commit this change. Git commit -m initial commit. So if you join big companies, they have a huge way of standardizing the way Git commits are made, they are pushed, and all those things. But since we are just starting off, I like to keep it simple. I'm going to just the message is going to be an initial commit. So if you've done that, so this file has been changed. So there are no files that are yet to be committed, or nothing has been changed, and we can look at the status also. That is, we have already, so if you look at the commit history, this is the hash of this particular commit. This is the branch that we are in, and it also says who's the author, when the commit has been made, and initial commit. So even suppose due to some accident your changes go away, as long as the git history remains, you can continue to keep this file there. So once you have done that, you want to have the commits, right? You want to push it to some of your friends online, but you're not able to do that, right? So that's where GitHub comes. But before doing that, this you want to maintain a master branch of whenever you're working on something, and also a feature branch if you're working on a particular feature where if you feel that you might make your code base unstable. So if you want to create a new branch, for example, I've initially worked with cats and I want to work with dogs. So what I do is I name the branch as dog branch, right? So I've created a new dog branch, and if I look at the now the commits have come from the main branch to the dog branch, and I see this particular thing. Let me go ahead and create another file called dog.python. Let me add dog.python, and let me commit the changes. Right, so I've now made 2 commits. So initial commit, which had the cat, and now the dog, right? So if I do an ls, you'll find cat.python, dog.python. So I created a branch from master to dog branch. Now suppose the changes that I made in this commit are unstable. I want to go back to a previous history. So what I can do is I can go to the master branch again. So if you now check the commits here, git log, it only has the initial commit. And if I want to look at the file, it only is cat.python. So if I want to bring back the change from the dog branch to the cat branch, what I can do is I can do a cherry pick. This is again a little bit advanced, but right, you probably will need to actually find out some use case to do that. So let me just show you what I did. So this is the commit for the dog, right? So I'm cherry picking this particular commit and done. So now if I look at the master branch and I do a log, I have both the dog and the cat files. So it might seem very complicated, and it might seem a waste of time, right? But suppose I can give you a use case. You're working on a final year project. You have 3 teammates, and you're working on a code base that is very complicated. it have more than 10, 15 files, and so two of you are working on the same codes, I mean, files concurrently at the same time, right? So suppose you are pushing, your friend is pushing his changes, and you also want to pull his changes, right? Doing that without Git is a very hard thing to do, right? But with Git, it makes life so much simpler, right? And also, every time before I used to do Git, I would name my files like, for example, cat.python. Next file, next thing, how I create a version history of it would be cat1.python, cat2.python. Same way that we do with Word documents, right? But that's not how we need to do that. This is a much more simpler and efficient way to deal with version history. So whenever you're working on a new project next time, especially if you feel that there will be more than a couple of collaborators and you were working on it over a long period of time, definitely go ahead and use Git, right? And if you want to understand or see how Git works, how Git commits are made, what are Git branches, you can definitely explore them online. All you just have to do is go online and search Git, right? You're going to end up with a ton of resources. So getting, there there are far too many links available. So you can go into any one of them and see how it works, right? This is the main place where Git, this is the particular file where you download Git. You also have a lot of documentation. If you just go into YouTube and type Git, right, you're going to end up with a ton of tools and videos and tutorials. So don't worry about it. So next time, as a thumb rule, whenever you're starting on a project, definitely start with Git. Okay, let's move on to the next one. Right. So I don't know how many of you have already come across GitHub, but as a second year, you might have definitely heard of GitHub. You might even have a GitHub account, but not sure how many of you have actually started working with GitHub. So what is GitHub basically, right? So as we worked with Git right now, and let me just go back to my terminal once more. I have my changes right here with me, but I have a friend who is in a different city, right? Now we are all working remotely or studying remotely. So how do I share my changes with him? So do I have to, copy this entire directory and email it to him, or put it in Google Drive and send it to him? I'm sure that's how we did a lot of collaborations when we were in college, right? But that's not a very easy and efficient way to do it. So that's where GitHub comes in. So all you need to do is we can create a repository. Of course, you need to set up an account and all those things. I don't want to go into that because that's very straightforward. So let me just create a sample repo, right? I will, for now, I'm making it private because just an example, I'm adding a README file, a git ignore, a license. Uh, Let me just go ahead and put Python, right? And create a repository. So right now I have a private repository, and so now what I can do is I can go to right before that. Now I can do git remote -v, right? So there are no remotes for that. Now I can do a git remote at GitHub, and I can paste this link right here. Right now it's done. So now I can push my changes to GitHub. Right now, all I have to do is refresh my changes. So I push my changes, and we have a file here called log.python, right? Just a minute. Let me switch over to the master branch. Now you can see my cat.python and dog.python. Now, once you've done that, if you want to collaborate with others, you can add people to your repository, right? You can go and invite a collaborator, your friend, your professor, add their username, and voila, you can share their code with others. And if they want to, uh, pull or work with your changes, all they have to do is go here and they can either download it or they can pull it, you know, using Git itself or with the GitHub CLI, and that's how you can collaborate with others. GitHub is not just meant for that. It is also a very powerful and a collaboration software also it has. Suppose you have a lot of you're working on a very big project and you want to feel that there are bugs, you test your project and you don't want to start work on it immediately. You can go ahead and create issues. So issues are basically right, create, we already created for dog and cat. Next we want to do it for a monkey. Create monkey.python, and we say why we want to do that, how we want to do that. We create an issue, or we find an issue in the dog.python. Fix dog.python. Uh, no, Labradors or no Alsatians, or this is how we can deal with issues. And whenever you want someone to collaborate with you and send over their code, you ideally want not to directly merge your code with theirs, right? You'd want to see the changes that they've made, so you can ask them to create a pull request or a push request, and that's how you do. Also, apart from that, you also want to create a project board. So this is a sample project board that I've already created, right? So if you want to track your progress, it's not very straightforward. So that's why this is I created a project board. So this is actually called a Kanban board. You might come across this in your software engineering class. What Kanban is, what sprints are, what is software lifecycle. But these are things that you would definitely come across when you're starting to work in a company, right? These are the tasks or the issues or the tickets that your project manager or your product owner or someone will get create, or you yourself will create. So whenever you start to work on something, you would pull it to the in progress state, right? And from once you start working on the in progress state, you might want to even create one more column and move it to testing. And once it is being tested, you move to done. So this is a very clean and clear way to track how the project is being progressing, and it gives a very clear idea, right? So suppose if you are working on a final year project or an internal funded project, anyone can come here and see whether you're moving or whether there's some progress or not, or what aspects or what issues that you have done, right? So if you're working on a final year project, I would suggest what you do is that you come here, you list out all the things that you want to do, right? And move, and whichever things that you're starting to do, you can move that to in progress, and the things that you have done, you can move to done. And suppose you want some clarifications from your professor or your in charge, you can create a separate column for that and move those things to doubts or discussions column, and then you can ask them. You can also share this with your professor so that they can also have a very good understanding of what stage you guys are. So this GitHub is a lot more than that, right? It also has something to provides a lot of CI/CD, that is continuous integration, continuous deployment aspects of it. So most of you, when you're running your software, you would run it in your local host or in a local machine, right? Uh, but that's not how the world works. So you would, if you want to create a Python file, you want to run it somewhere on the cloud or on some software or some machine, right? And access it in your machine. So in order to compile a code, build it, run it, that's where GitHub Actions come in. But again, I am not advocating just GitHub. There are a lot of options available like GitLab and other things. You want to explore and pick and choose what you want. Okay, let's move on to the next thing. So project design is a very, very crucial aspect of to complete and work on a project, right? So you need to pick an idea and implement a project. And the basic rule of thumb is never write even one line of code without designing and understanding the project, the requirements, etc. Always, start with the design, document the design, and then move on to an implementation, right? If we have time today, I will be going over the how to design an online quiz application for the class test, right? But provided we have time, we can do that, right? Next, we can, in order for you to actually, design, you need to understand the project, define the scope, the requirements, the functional requirements, non-functional requirements, and probably if there is some UI elements, you would want to, draw and design the UI actually before implementing that. This is not just for your college projects, but in companies, right? The project design phase itself might take about 30% of the total time of the project. The project design phase might be 30%, the implementation itself might be 40%, and the last 30% will be allocated to testing, deployments, and other things, right? So project development is not just all about coding, right? There's a lot more to it than writing programs. And the other thing that I want to introduce to you is something called draw.io, and since they have changed the companies, it's now called appdiagrams.net. So you might be having a lot of object-oriented programming papers or software engineering papers, and they'll be asking you to draw a lot of diagrams, and you might feel that, oh, it's a waste of time, and we are not ever going to use that. Companies only want people who can code, who can do who are very good in CodeChef or HackerRank or LeetCode or something like that, right? But in my second company, the very first task that I was given was not to write even one line of code, but I was asked to draw the swim lane, document the process flow of the company, and I was asked to come up with swim lane diagrams. So this is a very essential part of software development, and especially if you want to start working, you should also consider these aspects of it. So to give you a sample swim lane diagram that I came up with, so I documented I designed the document signing part, not the physical signing, but digital signing and stamping aspect of my organization, previous organization. So this is a swim lane diagram, and you see the different actors. The originator is basically the clients, the internal operation teams, and the third party who provide the APIs for the document signing. So here the internal team comes and uploads the documentation. The client comes and views the documents in the portal. They confirm and proceed to e-sign. They initiate signing and stamping, and this is to initiate to tell the viewers that there's some time involved in this process, right? And this is a parallel process. Both the clients and the internal team are both involved in signing the process documents, and the external third party will be the one who confirms whether they have signed or not, and both the clients and uh, the company is able to view the status of the documents. So these are things might seem very trivial, but are very crucial in software development, right? So without documenting the entire thing, without having a thorough understanding, never stop. Start writing one line of code. Also, this is something that we will come later as I move on, right? Also, this is a full stack development workshop, so you'll be working with front end, back end, right, and integrating them. So how does it work? So if you are going to start working on a project, how will that look? So to give you a brief understanding as to how the project architecture will look like in the coming weeks. So you will have a client that is a front-end application that will be running in your browser in React, right? And then that React application itself is going to be talking to the backend or the server using HTTP methods. HTTP is nothing but a global standard that is built on top of TCP/IP. So if you're a computer science or an IT student, you'd be knowing what those things are. And so if there is authorization and authentication happening, there'll be a filter there. Then you will have a REST controller. So REST controller is the aspect of your backend that will be dealing with the REST APIs and the HTTP methods, and then it will invoke a service in your server that will go to the repository and fetch the data from the database or manipulate the database and perform the action, and then will finally return the data to the client. So I was actually asked to come up with this design in my interview in one of the companies that I attended a few years ago, right? So ability to draw all these things is a very important aspect of software development, and these things also will be tested, not just whether you can write the code in the most efficient way or in the most fastest time, and there are other things that are far more important. So we have a few more minutes. So before I move on to the next things, I want to stop right now and get some questions from the participants. If anyone has, or if they can ask, this would be the right time.
Hi, someone who's very new to this. I'd like to know what a framework is.
Okay, a framework is a set of software or tools that help you do something in an opinionated way, right? So one such framework that is there is called Spring. So basically, Spring will so you do you know what a library is, for example? So yeah, can you just tell if you have an understanding of library? Can you tell me what a library is? From that, I will take you to what a framework is.
Okay, so libraries just contain like different functions and functionalities that can be implemented, right?
Right. So libraries are they are not opinionated, or they don't tell you how to do certain things. They just have features that you can choose to go and pick them. But frameworks are basically a collection of libraries. Also, they instruct you or define certain ways in which you can use those libraries to achieve a certain goal, or develop an application, right? So basically, the uh, Android SDK. So if some of you have worked with Android applications, the SDK itself is library, but there are only certain ways in which you can do that, right? So that itself is becoming a framework, right? Uh, so to give you an example in which, with terms that you might have come across, React is a library, and in the sense that it doesn't tell you what to do with it. It tells you, it tells you what to do with how things. It gives you. It's basically helping you do something. On the other hand, Angular is a framework. Angular has laid down fairly rigid rules in which how you can use those features offered by Angular and to do and achieve those things. Uh, the a lot of people working in the industry right now might not know that Angular is a framework and React is a library, because the definitions might differ on paper, but when you actually start implementing, they almost look the same, right? So let's not focus too much on the technical jargon, but let's the important thing is to get our hands dirty and start actually working. And as you start working, you will slowly come to understand why things are referred to as libraries and why things are referred to as frameworks.
Thank you.
Any other questions from anyone? Maybe if the organizers are at college, and if they can get some questions from any other participants, that would be great. Or if they themselves are interested and they have some questions, they can see, because I see only students from the college are able to speak, right? So if any questions, please do let me know. Because I initially thought of how to design an online application as part of the this current presentation, but since we have just around 5 minutes more, I don't think that would be possible. But maybe we can get our hands dirty and see what we can do. So everybody works with an LMS, right? So assuming that you are going to create an LMS, so what are the things that we need to keep in mind together? So whenever you're starting working to start on a software, find out who are the actors. That is, who are the set of humans that will interact the other with the application, right? So you'll have professors, right? You will have students, then you will have administrators, right? So always define, whenever you're starting with an application, design with start off with the actors involved. Don't start with any line of code. Don't start with the database design. Start off with define who are the people who will be interacting with the software. Next, you would want to have something like a swim lane diagram that is being present here. So let me just copy it and see if we can use the same thing here. You might want to see what will the professor do, uh, what are the actions of the students, and what's the administrator's job. Right? So let's get started. So in a learning management system, what will happen is the professor or the teacher will upload, or let's not even do a learning management system. Let's keep it even more simpler. An online quiz app, right, for your cycle test or your periodic test. So they will upload the questions, right? And we will have the students coming in. They will view the questions. What happens next is that they will attempt to answer the questions. Let's say once they attempt to answer the questions, they will be shown the answers to the questions of shown their own answers. And then let's see what happens. If it was an interactive session, I would be able to get points from you guys to to make it more interactive and easier. But let's go this way. Once they're shown the answers, each student's answers are shown to the professor, right? And then if it's a multiple choice question, the administrator or the system itself mark the answers and give a score, which will be then sent to both the professor and also the student, right? Even for a very simple use case where A professor uploads the questions, the students view the answers, they attempt the answers, and they're shown the answers. And when they click submit, I didn't go into the fully. So when they click on submit, the marks are automatically calculated by the system, and the students are shown the answers, and each the professor is able to view all the students' uh, responses along with the marks they have got. So even for such a small thing, in big companies or in any company, you would be expected to draw the swim lane diagram, and then as you jump into the technical aspect of it, you would be asked to draw the class diagrams, database diagrams, so on and so forth. Right before you even start with the architecture of the system, these things are the mandatory parts. Without this, your product manager or your business analyst won't even sign off on the use cases, and you won't be able to proceed with the project in a regular company. And that being said, since we have already reached the time limit, I will be stopping the session right now. And if there are any further final questions, please let me know right now. Or you can contact the organizers and they will compile the set of questions and I will answer them later. I'll also be sharing the slides with the organizers, and if they are students are interested, they can reach out to the organizers for the slides. But I think most of the things that I've told are already available online, so you can just go there and refer them. And I hope the session was interesting, and you will join the forthcoming session so that that's when you will actually get your hands dirty and do some things. I kept this in the first session very simple because most of you are in your second year, and I don't want to overwhelm you with any too many things. That's it from my side.
Thank you.
Thank you, sir.
Thank you guys for attending the session. So next week, Saturday, we'll be